This video will cover Space Combat Maneuvering, SCM, weapons systems, and tracking systems. We'll start with tracking systems. In general, your ship's tracking systems consist of two levels, one for monitoring all ship contacts in the area, and the other for monitoring a specific ship. While tracking all ship contacts, basic direction, threat, and range information is usually provided. While tracking a specific ship, more information about the ship is provided, along with additional details on the ship's position and movement. Such contact information is displayed across two systems, the heads-up display and the three primary cockpit displays. The heads-up display, also referred to as the HUD, displays information across the surface of your helmet's visor. The lower three cockpit displays show information at fixed locations as holograms in front of the projection frames here, here, and here. Most of the time, your goal will be to bring a targeted ship into the gunsight circle located in the center of the HUD here. The outer rim of the gunsight indicates where a target will be most vulnerable to your attack, while the crosshairs in the middle of the gunsight are used for precise aiming and alignment. Your helmet's visor HUD will keep the gunsight in the forward location where you need to line up with the target for attack, but it will display other details anywhere you turn your head to look around. You can see this in action now as I activate the mouse look mode with the default F10 key, then look around. Ships in the area are highlighted by direction indicators, as well as the current nav marker. And I'll recenter the view by pressing the F10 key again. The next tracking system we will review is the radar, located here in the middle cockpit display. The radar is positioned directly below the gunsight due to its importance in combat situations. The radar defaults to a 3D display mode, which primarily provides direction information on ships and range. When in the 3D mode, the letters DIR will be displayed here at the lower right, indicating the direction mode is active. The sphere in the middle of the radar screen represents the area of space around your ship. The galactic ecliptic horizon is displayed with a blue panel covering the middle of the sphere, dividing it in half horizontally. This helps provide you with a quick reference on the orientation of your ship relative to the galactic ecliptic. The blue circle with white markers at each 90-degree direction represents your ship's orientation. A contact in front of your ship will appear near the front of the circle at the top. A contact to the left or right will appear here at the left or right of the circle. And a contact behind your ship will appear at the back of the circle here. The small bright blue X-shaped indicator here at the front of the 3D radar represents the nose of your ship. This indicator is static and will remain in a fixed location since it always represents the direction your ship is facing relative to the 3D sphere that is calibrated to the galactic ecliptic. So the sphere will rotate as your ship's orientation changes from the ecliptic's horizon plane. Since our ship is currently aligned with the ecliptic, the horizon plane is level with the ship's orientation circle and nose direction indicator. So you can see that by default we are viewing the space around our ship from a perspective above and slightly behind it with a 360-degree directional field of view. If I roll right slightly, you can see that the sphere tilts to the left, indicating my ship's orientation has shifted so that the left wing is now above the galactic ecliptic and the right wing is now below it. And I'll level the ship out again. If I pitch the nose of the ship forward, the sphere tilts up, indicating the nose of the ship is now below the galactic ecliptic, while the tail of the ship is above it. Using the sphere in ship orientation guides will let you quickly determine the direction your ship is facing in relation to any contacts displayed on the radar. Contacts in the area will appear as small circles with lines that point to them in the direction they are at relative to your location in the middle of the sphere. All contacts will be displayed at the edge of the sphere to keep direction legibility consistent. For gauging distance, small lines are displayed around each contact circle. If no lines are present, the contact is at long range. If one set of lines is present, the contact is at medium range. And if two sets of lines are present, the contact is at close range. Each type of contact is color-coded. Ships will be green, yellow, or red depending on their threat level. Green contacts indicate ships that are part of your faction and are allied. Yellow contacts indicate ships that are independent and not linked to a faction affiliation, which generally indicates a neutral or unknown threat level. Red contacts indicate ships that are hostile, either because of their opposing faction affiliation or due to their attack state against you. Other contact types will appear white for cargo, blue for space station hangars, or purple for no identification. A legend is provided here at the bottom of the radar display for reference. So to use the radar in its default 3D direction mode to line up with the ship, you simply turn to bring the ship's corresponding contact circle into the nose indicator at the front of the display. I will demonstrate this now by bringing the ship linked to this contact circle to the front of our spacecraft. The ship is at a very wide angle and is slightly above our current position off to the right side behind us. So I will turn in that direction to bring the ship into view and put it in the gun sight once its contact circle is aligned with the nose indicator on the radar. The radar also offers a 2D mode, which primarily provides distance information on ships in range. To enable the 2D mode, press the default numpad plus key. When in the 2D mode, the letters DIS will be displayed here at the lower right, indicating the distance mode is active. The blue circle with white markers at each 90-degree direction is now flat across the surface of the radar display, indicating we are viewing the space around our ship from an exact overhead perspective. The x-axis runs left to right, and the z-axis runs top to bottom. There is no 3D sphere in this mode to indicate orientation changes or direction offsets, since the perspective stays locked to the galactic ecliptic in this mode. The 2D mode provides a more traditional radar display by simply showing the heading-based direction and distance of radar contacts, rather than including relative pitch and roll offsets. By reducing the contact information to a persistent elevation plane, you can quickly gauge how far you need to yaw the ship to align with a contact at a specific heading and range. However, you won't know the exact pitch or roll offset for alignment. This mode simply provides the precise heading and distance details for contacts in the area relative to the galactic ecliptic. So this mode is best used when you level your spacecraft with the galactic ecliptic and then scan for contacts. That way, you can view contact information with an aligned orientation best suited to the 2D distance mode that is fixed on the X and Z axis. At times, you may want to switch back and forth between the 3D and 2D modes to gauge specific direction and distance information for contacts in the area, depending on conditions. The readout at the lower left of the radar display labeled RNG is the current range value. The value of 10K is the default level and is also the maximum available radar range. Most ships and some objects mask their detectability via radar-absorbing materials, infrared-absorbing materials, and/or electronic countermeasures. This results in limited detection ranges, as well as limited target identification capabilities for many of the objects you will attempt to locate and track with radar, missiles, and navigation systems. At times, some ships may even further mask their detectability via cloaking and stealth technologies, making them virtually invisible to radar, thermal, and visual tracking. And certain environments can also limit the detection range of objects in space. For ship tracking, you will generally be able to retrieve the threat level, range, and direction information on the radar up to 10K. Optional long-range radar equipment is available to extend detection range out to 20K and even 40K. However, the contact information will generally be distance and direction only, without the capability to determine identification of friend or foe, referred to as IFF, beyond around 10K. To change the current radar range level, press the default numpad enter key. The range level will toggle to 8K, 6K, 4K, then finally 2K. Press the key again to return to the default 10K range. This option lets you filter out contacts by range so you can prioritize closer contacts with less clutter on the radar display. You can optionally hold the Alt key down to toggle through the range levels in increasing increments. The readout at the top left of the radar display, labeled NAV, shows the range to the current nav point. A yellow X-shaped indicator is displayed on the radar to provide the direction of the nav point. The readout at the top right of the radar display, labeled THC, indicates the total hostile contacts on the radar, which lets you quickly gauge how many hostile ships are currently in range. You can optionally filter out all other ship contacts except hostiles by pressing the default numpad minus key to enable the hostile contact only mode. While in this mode, the total hostile contacts, mode, and range values will all switch to red in color, and any friendly or neutral ship contacts won't be displayed. Press the key again to restore the default all contacts mode. All non-targeted ships that are tracked in range will have indicators displayed on the HUD over their directional locations. This way, you can quickly gauge their directions and frame types at a glance when they are in view. Like the radar blips, the direction indicators are also color-coded to the threat level of each ship being tracked. For additional reference, pathway markers will be displayed along with the direction indicators once a tracked ship is close enough to monitor and calculate full telemetry and physics tracking data for, which is usually about 7,500. The frame type of each ship is displayed below its direction indicator. The current targeted ship will have a larger indicator over its directional location, along with additional details on the indicator itself. At the top, bottom, left, and right of the indicator are the target shield array status bar graphs. These bar graphs will show the level of energy each shield array on the target has, with the top bar graph indicating the front array, left and right bar graphs indicating the left and right arrays, and the bottom bar graph indicating the rear array. At the top left corner of the target direction indicator is the range of the ship being tracked. At the top right corner is the hull damage level in percentage. At the bottom left is the AVL, or absolute velocity level of the ship. And at the bottom right is the FVL, or forward velocity level of the ship. More combat options and details on the current target direction indicator will be provided later in the video. The cockpit display at the lower right shows details about the ship you currently have targeted. The ship's frame type identification is displayed here next to ID, and its faction affiliation is displayed here on the right side. The threat level of the ship is displayed on the next line here. The forward velocity level, FVL, is displayed here, while the range is displayed here. The status of the ship's shield arrays is displayed here, with the top bar graph indicating the front array, left and right bar graphs indicating the left and right arrays, and the bottom bar graph indicating the rear array. The orientation of the targeted ship relative to your ship's orientation is displayed here on the direction indicator. The gray ship on the direction indicator will have the shape of the frame type of the targeted ship. When the targeted ship is flying directly at you and you fly directly toward it, its nose will line up with the white bars at the front of the circle here. So the perspective is from slightly above and to the left side of the targeted ship's position. If you turn away from the ship by about 90 degrees, you can see how the gray ship rotates to align with the new relative angle of your ship. Because the targeted ship is now flying at us from the right, the gray ship is pointed to the left. This way, you can tell what direction a targeted ship is flying while also taking into account the orientation of your ship. If you have a cargo or target scanner installed as equipment on your ship, the details will be displayed on the lines here next to scanner, once the targeted ship is in range of the scanning equipment. Below the scanner section is the subsystem indicator. To track a subsystem on the targeted ship, press the default U key to toggle through each of the three main subsystems. The status of the selected subsystem will be displayed in percentage here. The hull damage of the targeted ship is displayed here on this bar graph. The yellow bar will decrease in size as the targeted ship takes damage, and the gray ship on the direction indicator above will change color to yellow when the targeted ship sustains moderate hull damage, and red when it sustains critical hull damage. In addition to the default target detail mode, the display also offers a range list mode. To activate the range list mode, press the default G key. In this mode, the closest 10 ship contacts are displayed from nearest to farthest away. The ship you currently have targeted will have brackets next to its listing. Press the G key again to turn off the targeting system, which can help avoid accidental friendly fire. Press the G key a third time to turn on the targeting system and activate the default target detail mode. As reviewed earlier, there are two levels of monitoring used by your ship's tracking system: the primary ship target and secondary contacts for all ships in the area. By default, your ship's radar, HUD direction indicators, and contact list systems will keep track of multiple ships in the area, and a specific ship will be targeted automatically if the targeting system is active, as discussed in the previous section. You can then select a different specific ship to target from among the contacts in range. There are several ways to do this. The default T key will target the ships in range one at a time. The default R key will target the nearest ship in range. The Alt-T key combination will target hostile ships in range one at a time. The Alt-R key combination will target the nearest hostile ship in range. And to target a ship in the gun sight, simply line up the ship you want to target inside the gun sight, then press the default Y key. If multiple ships are in the target area, simply turn your ship so the one that you want to target is closest to the middle of the gun sight, then press the Y key. The nearest hostile and gun sight targeting options are recommended for optimal target selection in combat situations. Some objects in space can also be targeted using the ship tracking system, such as asteroids and station modules, and at times you may want to target such an object for attack or navigation. To target an object, you can use the default numpad 0 key for objects in range one at a time, the numpad 1 key for the nearest object, or the numpad 3 key for an object in the gun sight. If a targeted object exceeds tracking range or is destroyed, the system will default to a ship in range. There are two types of primary weapons you can install on your ship. The first type is a particle cannon. Particle cannons fire highly charged energy bursts at rapid velocity. Particle weapons include technology to automatically aim at a moving target and apply physics offsets to provide exact gunsight point of fire impact precision. This results in the pilot being able to have computer assistance aiming, as well as being able to place shots directly where they aim with the gunsight, regardless of their ship's speed and relative vector. The second type of primary weapon is a beam cannon. Beam cannons fire highly charged laser pulses. Since these weapons move at the speed of light, they do not need to lead a target in order to anticipate an impact. They can simply aim directly at a target in range to inflict damage. A drawback to these weapons is that they can be easily reflected or diffused, dispersing their energy. So they generally don't do much damage to spacecraft hulls or other solid objects that are designed with strong reflective surfaces. However, their high energy beams can be effective against small and even capital class ship shield systems. But in order for them to be effective, they must harmonize their two beams to meet at a specific point on the surface of a shield array in order to inflict enough concentrated energy damage. This means that the beam cannons must be locked by the ship's aiming and tracking system to align this way, as it would be impractical for a pilot to perform such precise alignment manually. The automatic aiming and tracking system, referred to as the MDTS, will be reviewed later. The current firing mode for your primary weapons is displayed here on the HUD in Mode 2, and here on the lower left cockpit display. The default mode is All, which fires both the particle cannons and beam cannons at the same time. The default left control key will fire the primary weapons with the current firing mode. When you hold the button down, each weapon type will fire as soon as it can, based on the rate it is capable of. To cycle through the firing modes, press the default N key. When the indicators display part, then only the particle cannons will fire. When they display beam, then only the beam cannons will fire. As reviewed earlier, the current target direction indicator provides immediate velocity, hull status, and shield array status information about the ship you are currently targeting. When your primary weapons obtain a tracking lock on the target, a lead indicator will appear to provide the optimal aim point for particle cannon gunfire. The ship's targeting system will calculate the optimal aim point based on the target's speed, distance, and vector. The indicator will be displayed with an arrow that points in the direction the targeted ship is headed relative to your position and perspective. You can aim at this point manually with particle cannons, or have the targeting system do it for you. Beam cannons will also be locked, but since they move at the speed of light, no leading is necessary. The beam cannons will simply aim directly at the targeted ship's shield array to harmonize an impact point when the tracking lock is secured. By default, your ship automatically aims particle cannons and beam cannons at a ship being tracked with a multidirectional targeting system, referred to as the MDTS. The indicator for the status of the MDTS is displayed here. It will display MDTS ready when the system is active and waiting to track a ship, and it will display MDTS locked when it is automatically aiming your primary weapons at a targeted ship. To have the MDTS track a targeted ship, you must bring the ship's direction indicator into the outer rim of the gun sight, and the ship must be within range of the current primary weapon. If the indicator is not displayed on the HUD, then the MDTS is turned off, and you'll need to manually aim weapons. You can press the default L key to turn the MDTS system off and on. The list of secondary weapons you have loaded on your ship is displayed here on the lower left cockpit display. The weapon listed in the first slot at the top is the one that is armed and ready to fire. If you have a missile with tracking capability loaded on the first secondary weapon hardpoint, the target direction indicator will also display missile lock status indicator brackets once you reach the targeting range of the armed missile. The missile lock indicator brackets will gradually decrease in size as the lock is being secured. Then they will spin once the lock is secured and the missile is ready to fire. A missile locked indicator will also appear here on the HUD. You'll need to keep the ship being tracked inside the forward view angle of your ship in order to maintain the lock and not let the ship exceed the range of the missile that's ready to fire. If either condition isn't maintained, then the lock will be lost and you will have to start over to obtain a new lock. You can cycle through the secondary weapons you have loaded on your ship with the default semicolon and apostrophe keys to arm a different weapon as desired. An important element to effective combat is balancing your ship's energy reserves. Each ship type can have a different level of available energy to divide between its two main systems. but any spacecraft will generally need to divert energy to one system or the other during combat as conditions change in battle. Your ship divides energy between its shield system and weapon system. Diverting energy to the shield system will improve the recharge rate for all arrays, while diverting energy to the weapon system will improve the recharge rate of your primary weapons, providing more shots over time. By default, energy will be evenly balanced between the two systems, and the energy bias readout here will display 0S and 0W. To increase energy to the weapon system, press the default right bracket key, and to increase energy to the shield system, press the default left bracket key. When power is taken away from one of the systems, the value next to its corresponding letter will decrease by 1, and the value next to the other corresponding letter will increase by 1. So if I now increase energy to the weapon system by 1 step, you can see that the value next to S now reads -1, and the value next to W reads +1. You can adjust energy by up to +5 or -5 to or from each system. Each ship can have different recharge rates and storage capacities for these systems, depending on which frame you choose and how you configure it with options such as energy cores, shield batteries, a cannon relay, and/or a cannon heatsink. So it's important to spend some time practicing with the configuration you select and balancing energy between the two systems for times when you want more shots during attacks and for times when you may want to recharge shields faster. Your ship's shield system divides its spherical protection field into 4 directional sections, referred to as arrays. Each array takes a portion of the available energy and projects a 90-degree protective field in the forward, left, right, and rear directions, as illustrated in this image. The status of each of your ship's shield arrays is displayed here around the gun sight in HUD Mode 2, with the top indicator showing the front array, left and right indicator showing the left and right arrays, and the bottom indicator showing the rear array. The shield array status is also indicated in the lower left cockpit display here. In addition to increasing energy to the shield system as a whole, as reviewed earlier, you also have control over how much energy is provided to each individual array. To demonstrate this option, I will reduce energy to the shield system to slow its recharge rate, then drop the shield arrays by briefly activating a stealth generator. With the arrays at low power and slowly recharging, I can boost energy to the front array by taking it away from the other 3 arrays. This is done with the default numpad 8 key. Each time I tap the key, energy is taken from the left, right, and rear arrays and applied to the front array. You can do the same transfer using the default numpad 4 key for the left array, numpad 6 key for the right array, and numpad 2 key for the rear array. You can also equalize energy between all of the arrays with the default numpad 5 key. A small amount of energy is lost in the transfer, but this can be an effective way to protect against weapon attacks from a specific direction, or to boost power to the front array if you enter a planet atmosphere at high velocity and need additional forward shielding. It's important to keep track of each of your ship's shield arrays so that if one becomes critical, you can quickly transfer more energy to it. In the cold backdrop of space, heat is an effective way to track powered objects. Monitoring heat is the primary way missiles track targets. Your ship generates heat with its energy systems, weapon systems, and engines and thrusters. Some of the internal heat generated by your ship is masked to avoid tracking by enemy missiles. However, your ship's heat profile can increase dramatically when you use thrusters, engines, and/or weapons. When more heat is generated, your ship will be an easier target to track by enemy missiles. The level of heat generated by your ship, referred to as the heat signature, is displayed above the gun sight here. When your ship is at the coolest level it can operate, the bar graph will appear fully green. As more heat is generated, the green bar will gradually be replaced by a yellow bar. Once the heat level is very high, the bar graph will be filled in with yellow and the indicator will change color to red. Since missiles primarily use heat for tracking, keeping your ship's heat signature low is an important part of missile evasion. By default, your ship is also equipped with anti-missile countermeasures, which attempt to distract incoming missiles with a strong heat source, while also directing high-energy pulses at them in attempts to cause them to explode before they hit your ship. The more countermeasures you launch, the more effective they will be. Use too many though, and you may run out before a battle is over. It's best to use countermeasures when missiles are at close range, but still far enough away to give the countermeasures time to be most effective. Avoid flying directly at an incoming missile and then using countermeasures, since your ship will be between them and the missile. Instead, launch countermeasures when you are perpendicular to a missile or it is behind you. If there is time, turning away from an incoming missile can provide more time for the countermeasures to distract and destroy it. Quickly lowering your ship's heat signature while using countermeasures can be additionally effective by reducing the tracking signal of your ship, which increases the relative heat signals of the countermeasures. To do this, simply disengage the IDS to immediately shut down active thrusters and engines, do not fire weapons, and avoid making turns to keep your ship's heat signature as low as possible. Once the missile is detonated, you can then resume IDS control. You can also shoot down enemy missiles, although this requires significant time and energy reserves, especially if there is more than one inbound missile. Missiles are armored and require multiple hits to destroy them, so make sure you have enough time and distance to successfully destroy them before attempting to do so. And also consider that by turning to face a missile to try and shoot it down reduces the potential effectiveness of any countermeasures you may launch. Stealth devices are available as either a reusable generator equipment item or as single-use field units mounted on secondary weapon hardpoints. The generator operates by using the ship's energy system and shield arrays to project a cloaking field. It will last as long as there is energy to power it, but the shield arrays will be fully drained when the device is deactivated. It will also deactivate if you use the afterburner or engage the jump drive. The stealth field units are time limited and do not consume energy or use the shield arrays. However, they are limited to only being used once. Stealth devices can allow you to travel through hostile space undetected, complete spying objectives, and ambush enemy ships. When your ship's shields are critical, weapon fire can impact its hull directly and cause damage. The damage level of your ship's hull is displayed in percentage here on the gun sight, and by a bar graph next to the letters HUL here on the lower left cockpit display. The indicators aren't a percentage of how much of the surface of the hull is damaged, but instead provides a percentage of its overall structural integrity. If the value falls below about 50%, then your ship's equipment, subsystems, weapons, and cargo can be vulnerable to damage or destruction. If the value falls to 0, then your ship can no longer sustain its structure and protect its internal storage tanks. When that happens, your ship will break apart and its fuel, life support, and power sources will ignite, causing it to explode. The damage level of your ship's subsystems are displayed in percentages here on the lower left cockpit display. NAV stands for navigation, WPN stands for weapon, and ENG stands for engine. When the navigation subsystem is damaged, the compass, radar indicators, and pitch ladder will not be able to align with their respective directions and will bounce around. When the weapon subsystem is damaged, your primary and secondary weapons will not be able to fire intermittently. When the engine subsystem is damaged, your ship's engines will not be able to consistently maintain thrust. The level of damage determines the severity of loss and functionality. For example, if your engine subsystem has around a 10% status, the engines will only be able to engage for very short intermittent bursts. When damaged in this way, the engines will take much longer to adjust your ship's velocity. If you have a repair system installed on your ship, the percentage will gradually increase and the engines will operate more consistently as repairs are made. We'll cover Space Combat Maneuvering, or SCM, next. We'll also cover a few principles for atmospheric combat, as well as several other environmental factors and options. Some combat maneuvering tactics used in the era of aircraft are applicable to spacecraft, but there are many new challenges and differences. Unlike the atmospheric environment of aircraft, open space is a fully 3D environment, without the obstacle of terrain or limit of high altitude to confine the vertical range of movement. So as a space combat pilot, you are free to utilize a full range of directions and velocities. Your primary focus should be on maintaining correct velocities for the maneuvers you need to perform to obtain either the optimal attack position on your target or to escape with effective evasion techniques. In space, there is no atmosphere to generate lift or drag, so any changes in your ship's course require using thrusters to modify. Different thruster systems can provide different performance results for those maneuvers. Your ship's mass will also have a significant impact on how fast you can perform maneuvers, and some may not work very well or at all for certain ship frame types. So make sure to consider these factors when planning your space combat strategies. Here are a few points to keep in mind during combat. Speed is critical. Always keep moving. Try to avoid making sharp turns with the IDS on, which risks slowing you down to speeds that make you an easier target. In active combat, you will rarely want to allow your speed to drop below 1,000. Instead, keeping speed higher. However, the faster you fly, the longer it will take to perform turns at a consistent speed. If you fly too fast, you won't be able to make turns quickly enough for an effective attack placement. You'll want to balance your velocity with the turn rates you want to make to avoid overshooting the target. Remember to use the afterburner when needed to maintain a high speed, or regain it if too much is lost. The first combat tactic we'll review is offset approaching. You should never fly directly at a target with guns blazing. Those who do will often discover just how easy they are to destroy by making such a rookie mistake. You should never approach a target directly, since that allows your opponent's MDTS to more easily maintain a predictable vector on you, making it easier for them to hit you with gunfire. It also reduces the time you have to evade missiles and use countermeasures, and it leaves you less time to counterattack. Instead, you should always approach a target at an offset angle. Generally speaking, the wider the angle, the better. Too wide, however, and you may find yourself backing away from your target. I will demonstrate this concept against the hostiles here. Notice how I approach at a fairly wide angle with my FPM marking a course far off to one side of the target. I'll build up some speed, and then feather the lateral thrusters as I turn to maintain the offset approach, while simultaneously pointing the nose of my ship at the target. Once I get in range and the MDTS indicator switches to lock, I begin firing. I'll start with beam cannons first to drain the target's shields. Then, once an array is red or near red, begin firing with particle cannons. You can see that I've inflicted a significant amount of damage on the target. I'll turn around to face the target again, then repeat the same process by offsetting my approach, then opening with weapon fire once in range. And eventually the target is destroyed. When performing offset approaches, your target may be flying faster or slower, so you'll want to manually control the maneuvering thrusters while drifting to adjust your course as needed to maintain the best offset angle. At times, it may even be beneficial to turn off the IDS entirely to maintain a direct course. This tactic works well against a limited number of hostiles, but may not be the best choice in situations involving a higher number of hostile ships. So always keep an eye on your radar and maintain situational awareness. The offset approach can also help with a quick escape, if needed, by simply turning toward the direction you're drifting and engaging the afterburner to put some distance between you and the attacking ships. Next, we'll cover effective techniques for wide arc and reverse attacks. One of the best ways to fly an attack run involves flying a wide arc around your target while maintaining or slightly increasing the range. This maneuver takes some practice to perform consistently and effectively, but once mastered, it will be a very useful option in combat as it helps maximize the time you have to inflict damage on a target while simultaneously minimizing the time your target will have to return fire on you. I'll demonstrate this maneuver now. You can see how I've plotted an offset approach angle and now adjust it as I fly by the target to transition to a wide arc around them. I'll adjust my arc to try and stay in primary weapon range of the target and attack when possible. You can see that the target is unable to effectively return fire. At this stage, I can gradually transition to flying backwards. I'll decrease my speed a bit to allow the target to approach slightly, then adjust my speed once they get in range to try and maintain the distance. From here, I can engage with weapons while flying backwards to finish off the target. This technique can work pretty well in wide open space, but carries some risk if there are objects around you such as stations, asteroids, or other hostile ships. Colliding with an object can result in either a severe speed reduction or your destruction. Hostile ships approaching behind you can also engage with missiles or cannons, and with a direct approach vector to them, you'll be an easier target, so make sure to pay attention to what's around you when flying reverse maneuvers like this. Next, we'll review chase tactics. One of the best positions to achieve is the 6 o'clock on a target. You'll usually have the opportunity to approach a target from behind after a flyby when you turn around to reacquire, or when they are focused on attacking a different target and you are approaching from a distance. Chase attacks can be difficult to set up and maintain, but are an important part of the attack strategies you'll need to be aware of, as they will often also be used against you. If you catch an enemy ship flying at a near perpendicular angle, you can approach them for chasing using lead, peer, or lag pursuit angles. Here's an image showing the differences between each approach. You'll need to decide which approach is best to use based on distance, approach velocity, and flight angles between you and the enemy ship. Lead, peer, and lag pursuits can be done from above, below, or to one side of a target ship. A lead pursuit will allow you to meet up with the target ship significantly ahead of where it is flying, which is a good option for attacking with primary weapons that need to lead the target anyway. As soon as the lead indicator appears, you'll be ready to engage with primary weapons. A peer pursuit will allow you to fly directly at the target ship. This can be an effective option for attacking from above with missiles, particularly against an enemy ship that is focused on another allied ship. A lag pursuit will allow you to fly in behind a target ship. When timed well with speed and distance, this can set up an optimal angle for a missile and/or gun attack at the target's 6 o'clock. Getting in behind an enemy ship can be useful, but your opponent won't often let you remain there for long. If they are accelerating to try and get away from you, it will often be difficult to chase them down and effectively attack. They'll usually try to spin and or accelerate with afterburner to avoid incoming gunfire, and to get far enough away to turn around and reacquire you. Be sure to remain aware of the closest threats. You can do this with a 3D radar, 2D radar, and or the contact range list on the lower right cockpit display. Enemy pilots will often watch for the nearest threat as well, so once you get close enough, they will likely turn to attack you. But sometimes, especially if they are attacking a capital ship, they will remain focused on their target, and you'll have an opportunity to sneak in for an attack. So watch for these opportunities as you engage in battle. Also be sure to watch for objects in space that you can use for shelter and escape. If asteroids are nearby, you can fly through them for cover and possibly even cause enemy missiles to collide with them. You can even use station modules for cover as needed. Nebula clouds can be particularly useful for hiding your radar signature, as it will generally decrease the detection range by 50%, but that also means your radar's detection range for enemy ships will be reduced as well. However, they can be a good place to escape for repairs in open space. Flying near planet terrain can be another option. You can fly close to the terrain to limit your exposure to attack from hostile ships. Flying inside canyons or around mountains can provide additional cover. Applying the right strategy in a combat situation is not an exact science. You need to constantly adapt to the changing conditions of the battle and remain aware of where enemy ships are in the space around you, where they are moving, and what threat level they pose to you and any friendly ships that may be flying with you. Dynamic decision-making for changing combat conditions is a major factor in a pilot's success rate. Remember that in Evochron, time is credits. While some tactics can prove effective over time, they may take longer to complete, and in the long run, wind up costing you credits since you may only be able to complete half as many contracts in the same time period. You'll want to formulate attack strategies that work effectively and quickly to maximize your time efficiency. Taking longer can also mean you give your enemy more time to call in reinforcements, resulting in a situation that seemed easy at first, soon turning into a much more difficult objective to complete. That concludes this video. For more information, review the instructions included with the game and visit Evochron.com.